Hi everyone and welcome to the internet. What we're going to be doing in today's lesson is having a look at chemical formulas. So hopefully by the end of this lesson you're going to know how to actually write the formula for a variety of different chemical compounds. To start us off though, I want you to write down everything you know about chemical formulas in your book. So I'm going to give you 2 minutes, write down everything you know. So a chemical formula is actually really important and really informative to us, because just by looking at that chemical formula we get a whole range of information. Now I'm hoping you have got at least some of these 5 down. First thing is it tells us the number of atoms there are, so we know exactly how many atoms make up that chemical. We know how many different elements it's made from, and we know the names of those elements. It also tells us how many atoms of each element make up this chemical. And when we come on to do C6, then we're going to learn a little bit more about the structure of the chemical and how the formula tells us about that too. So what we've got is a whole range of different bits of information there about what a formula can actually tell us. So give yourself a mark out of 5, and any you're missing, obviously jot those down as well. I'll leave it up for another minute so you can get them all written down. What we're going to start off with is going back to the very basics about our elements, their symbols, and the formulas that we can use. Now I'm hoping that a fair amount of this is just going to be a recap on what you've done already at Key Stage 3 and hopefully already know. But just in case, we'll make sure we go over it so you know these fundamental concepts. When it comes to a chemical symbol, then they've got 1, 2 or 3 letters. So when we look at any element on the periodic table, you'll notice that the chemical symbol for those elements have either 1 letter, 2 letters, or 3 letters. And when we look at those symbols, then the first letter is always a capital letter. If it has a second and a third one, then they will always be lowercase. And this is one of those real fundamental rules that a lot of people forget when they're in an exam, and therefore they're going to be potentially throwing away marks. The examiners do have a little clause in the mark scheme that says that we can forgive some minor inaccuracies in notation, but if you've written everything in full capital letters, I would expect to lose marks there. So get into the habit of using the proper scientific notation. So the first letter of any element symbol will be a capital letter, and if it has a second letter, then it's going to be lowercase. You're not going to be asked to write any with 3. I've not seen it yet on a GCSE paper, but if you did, again, lowercase for the third. So first letter, always a capital, others always lowercase. So make sure you've got those 2 points written down. Let's put that into practice then. There are 6 different elements on the screen there. I would like you to have a go at writing down the chemical formula for those elements. Now, I'm hoping that these are ones that you've already encountered and therefore may already know. And I know that I make my lot always learn the first 20 elements and their symbols. Even though you get a periodic table, it saves you time in the exam. So learn them just so that you can save yourself those valuable few seconds or maybe minutes if you're quite slow at reading the periodic table in an exam. Have a go, write down the symbols for these 6 elements. I'm going to give you just about another minute and a half to do that. Okay, let's mark those then. Obviously tick any you got right so that you can obviously give yourself a score out of 6 at the end. So carbon is a capital C. Helium, capital H, lowercase e. Sodium is a capital N, lowercase a. Not S's, because sodium goes with the Latin name natrium, hence why it's Na. Potassium is a capital K, again, not the P, go careful. Chlorine is a capital C, lowercase l, and copper is capital C, lowercase u. So add up your score out of 6 and write that in your book for me. The next thing that we're going to come on to consider are metals. Now, as we've said, when we're looking at the number of atoms of any particular element, they've got that little subscript number, the number in the bottom right corner. But with metals, we always write it as the empirical formula. And the reason for that is that metals exist as these structures called giant metallic lattices. And by that we mean in a small piece of metal, then we've got potentially thousands or millions of actual atoms of the metal. Now, we're not going to write that little number after the actual symbol because it's just made of that one metal atom. So what we do is we use the empirical formula, so the simplest ratio of those elements. Because it's only the one element present, we just write the symbol for it. So dead easy, if you've got any of those metals, the actual symbol is just the one on the periodic table. So if it was iron, Fe, if it was magnesium, Mg, dead easy to remember those ones. And again, the reason that we've got there for not using the numbers is because they would be really big. And big numbers lead to errors when you write them down. Add to that, if we change the amount of metal even by a tiny amount, we change the number of atoms by a significant amount. So we don't ever write the numbers there, it's always just the empirical formula for the metals. So make sure you've got those 2 sentences in your books for me. When we come to group 0, so that is the group on the far right hand side of the periodic table, also known as the noble gases, then they exist as individual atoms. So every single one of those, all we've got to do to get the correct formula is just write down the symbol from the periodic table, because they exist as a single atom. If we go one group to the left to group 7 there, the halogens, then these exist as something called diatomic molecules. So di meaning 2 and atomic atoms. So these are 2 atoms that are covalently bonded together. And it's a covalent bond because they're nonmetals. So good example of that is chlorine. So rather than just writing Cl for chlorine, because it's a diatomic molecule, it's always going to go around as that pair of chlorine atoms. So we must write it Cl with a little subscript 2, so a little number 2 to the bottom right there. Now that's true of a number of other gases. So things like our oxygen, hydrogen, nitrogen, any of our group 7 elements, they're all diatomic. So that means whenever we write their formula, we must have the subscript 2. And please learn that now, because where we're actually just starting C3 at this point, this is something that will come back and bite you if you don't learn it in C4, in C5 and in C6. So make sure that you know if it's group 7 or if it's some of those common gases, then they go around as diatomic molecules, always with the subscript 2. So write down those first 3 sentences for me and then have a go at writing down the formulas for oxygen, hydrogen and nitrogen for me. So, as we already said, these are all diatomic. So, oxygen is a capital O with a subscript 2. Hydrogen, capital H with a subscript 2. And nitrogen, capital N with a subscript 2. So, give yourself a mark out of 3 based on how many you got right there. When we talked about the metals being in this giant structure, they're not the only things that exist in these giant structures. We've also got some non-metal elements that exist as a giant covalent structure. So again, if it's a giant covalent structure, we don't write all of the numbers after the symbol, we just use the empirical formula again. And a really good example of that is carbon, so we just write it as a capital C. If it's phosphorus, this is one I suggest you remember, then we would write that as P4, so a little subscript 4 there. So make sure you got those couple of points written in your books. When it comes to actually writing a formula, then one of the most common ones that you are going to see in chemistry is what's called the molecular formula. So this is where we've written out the number of atoms and the different elements. So this would be something like H2O, for example. So the ones we're really familiar with seeing, they're the molecular formulas. And these are actually really important and very informative to us as chemists, because when we look at a molecular formula, we can see the symbols for the elements and the number of atoms of each element present as well. So it's giving us that initial bit of information. What elements is it made from and how many atoms of each element are there? Obviously from that we could also work out the total number of atoms that make up that chemical too. So make sure you've got those couple of points written in your books. Let's start with an easy one. Write me the molecular formula for carbon dioxide in your book. Just going to give you 30 seconds to do that. hopefully we know carbon dioxide has the molecular formula CO2. So capital C, capital O, and then subscript 2 after the O. So what that tells us is we've got one carbon atom which is joined on to 2 oxygen atoms. Grand total of 3 atoms altogether. Okay, let's have a practice at looking at these molecular formulas, working out the different elements we've got and the total number of atoms. So in the table then, what we've got are a range of different molecular formulas, and I've done the top one for us for carbon dioxide. So in our first column, we're going to write down the number of different elements. In this case, we've got 2. You can spot them from the capital letters. The name and the number of each element then, we've got carbon, and there's 1 carbon atom because there's no number to the bottom right of the C, and we've got 2 oxygens because there is a 2 to the bottom right of the O. In terms of the total number of atoms for our final column, then we've got 2 oxygen plus the 1 carbon gives us 3. So have a go at the others for me. You can do it in a table or you could just write it out if you prefer, but I'm going to give you about 4 minutes to have a go at this. Okay, let's check those answers then. So H2O has 2 different elements. We've got 2 hydrogens and 1 oxygen and 3 atoms altogether. HCl has 2 different elements. Hydrogen is 1, chlorine is 1, and there are 2 atoms in total. NaOH is 3 different elements. We have 1 sodium, 1 oxygen, 1 hydrogen, and 3 atoms altogether. CuSO4 is 3 different elements. We have 1 copper, 1 sulfur, and 4 oxygens, which gives us 6 atoms in total. C6H12O6 is 3 different elements, 6 carbon, 12 hydrogen, and 6 oxygen, and 24 atoms altogether. Li2O is 2 different elements, 2 lithiums, 1 oxygen, and 3 atoms altogether. And finally, CaCO3 is 3 different elements, 1 calcium, 1 carbon, 3 oxygens, and 5 atoms altogether. Now, that always used to be a favourite on the exam papers. And obviously we haven't really seen many of the new ones to know whether it's still going to be that recurring theme. But being asked how many different elements and how many atoms a chemical formula is made up of was always a go-to question. So it's a really good one to know, and it gives us that extra bit of information about the chemicals we're dealing with. So make sure you know how to do that, and obviously add up your scores and give yourself a total. I'd suggest what you do is give yourself 1 mark for each of the boxes. So that means that you've got a total of 3, 4, 5, 6, 7 for the different elements, 7 for the name and number of each element, and 7 for the total number of atoms. So that's 21 marks altogether for that table. One of the reasons that I really love chemistry is because it's great in terms of just learning rules. If you know the rules, then you know how things are going to work. So what we've got on this screen are just a range of the rules that we can learn. They're going to be really useful in helping us out as we carry on and go more in depth with our chemistry understanding. So what I'd like you to do is write down each of these sentences and fill in the 7 blanks that are there. So we've got 8 bullet points to write down, 7 of them have got blanks. Have a go at filling them in from what you know. let's make sure we've got all those right then. Obviously, tick any you've got right, any you've got wrong, make sure you correct them, because if you've got this set of rules, it's going to be immensely useful to you throughout chemistry. So, first one, hydrogen ions have a +1 charge. Elements in group 1 have a +1 charge. That's because both of those are going to lose 1 electron to form the ion. If they're in group 2, it's a +2 charge, and group 3 elements have a +3 charge. So we can work out that on the left hand side of the periodic table, the group number tells us the charge that will be on the ion if we stick a plus in front of the group number. So group 1, group 2, group 3, stick a plus in front of it and you've got the charge on the ions for that group. The transition metals, that's the block in the middle, the kind of low rectangle on the periodic table, then these usually have a +2 charge. But there are exceptions. And the way we will see those exceptions are that they're going to use a number in Roman numerals in brackets. And that tells us the charge on the ion. So where I've shown you iron with the 3 in Roman numerals in brackets, that would form Fe3+ ions. Whereas if I'd only given you iron with 2 in Roman numerals in brackets, it'd be Fe2+ ions. Then as we come on to the right hand side of the periodic table, group 5, group 6, group 7, they're all negative charged ions, and all you need to do to work out the charge is 8 minus the group. So 8 minus 5 is 3, so elements in group 5 have a -3 charge. Group 6, 8 minus 6 is 2, so it's a -2 charge. And group 7, 8 minus 7 is 1, it's a -1 charge. And the reason they're all those negative charges is that when the ion forms, they gain electrons. Again, to give that full outer shell, so up to the 8s, obviously, is going to be 1 more electron in group 7, 2 more electrons in group 6, and 3 more electrons in group 5. So make sure you've got all those written down and ticked any that you got right. The last type of ion that we need to be aware of are the compound ions. Whenever we talk about a compound ion, we're talking about one that contains more than one element. And what I've given you in that table are the 5 you must learn. Not just their formula, but the charge on it as well. So ammonium, hydroxide, nitrate, carbonate, and sulfate. These are the compound ions you must know off by heart. So ammonium is NH4 with a single positive charge. Hydroxide is OH with a single negative charge. Nitrate, NO3 with a single negative charge. Carbonate, CO3 with 2 negative charges. And sulfate, SO4 with 2 negative charges. So make sure you've got those written down, highlight it, put it in a box, do something that makes it stand out so you know you've got to learn them. And one of the best ways to do that is to create yourself some little flashcards. On one side, put the name of your compound ion, on the other side, the formula as it is in the table there, and then you can just sit and test yourself on it until they stick. If you do that regularly, there's only 5, it only takes you a couple of minutes to do this, then they will get stuck in your long-term memory. So start early, get learning these ions. The reason that we care about all these charges that we've got on different ions is that when we come to write a formula for an ionic compound, we've got to make sure that the positive and negative charges cancel each other out. So they've got to be the same number of positives as there are negatives. If we've got compound ions present and we've got to balance it, so we don't have enough, we've got to have 2 compound ions, for example, then what we need to do is put brackets around the formula of the compound ion and then the number to the bottom right. So I've given the example of calcium hydroxide there. So calcium has a 2+ charge, hydroxide a single negative charge. So to cancel it out, we need 2 hydroxides. So we put the OH of our hydroxide in brackets, and then we put a little 2 to the bottom right of that formula. And that means that we've got 2 hydroxide ions, therefore we now have the 2 negative charges joined on to the 1 calcium ion which has 2 positive charges. So always must cancel out the positives with the negatives. Let's put what we've learned into practice. Write me the formula for calcium chloride. So when it comes to writing the formula for calcium chloride, the first thing we need to do is identify what group calcium and chlorine are in. So you can look at the periodic table and we're going to find that calcium is in group 2, and we'll find that chlorine is in group 7. Now what that tells us then is that what we need to do then is work out the charge on the ions. So if calcium is in group 2, it's got 2 electrons in the outer shell, so it's going to lose those 2 electrons to form Ca2+ ions. Chlorine is in group 7, it has 7 electrons in the outer shell, therefore it's going to gain 1 electron to become Cl- ions. Now what we need to remember is that when those two come together to form the actual chemical, what we need to do is make sure that the number of positive charges are cancelled out by the number of negative charges. So we've got 2 positives and 1 negative, so what we're going to have is 1 calcium is going to join to 2 of the chlorine, and because we've got 2 chlorine, the little 2 goes in the bottom right of the symbol for chlorine, Cl. So that tells us we've got 2 chloride ions, each has a single negative charge. So really what we're saying is we've got those 2, so 2 minus charges, 2 positive charges, they cancel out to make Cl2. And that's how we work out the formula for the ions, making up the actual final chemical. Okay, just to finish off today then, we've got our plenary questions. Those of you with target grades up to a grade 5, it's the column on the left. Those of you with target grades over a grade 5, it's the column on the right. So I'm going to leave these up for a couple of minutes today, but as always, if you need longer, just hit pause on the video and take as long as you need to answer them.